Imagine having a personal assistant that not only retrieves the exact information you need, but also crafts it into the perfect, highly relevant answer for you. Welcome to Retrieval Augmented Generation, or RAG, a cutting-edge technology that merges the power of AI-driven generation with the precision of document retrieval systems. Whether you're an AI enthusiast or just curious about how this revolutionary technology works, in today's video, we're going to dive deep into RAG, what it is, how it works, the different types of RAG models, and why it's becoming essential for industries needing domain-specific knowledge. So, what exactly is Retrieval Augmented Generation? RAG is a hybrid approach that combines the power of two AI methodologies: retrieval-based systems, which fetch information from external knowledge sources, and generation-based systems, which use AI models like GPT or BERT to generate natural language text. Think of it this way: when you ask a question to a traditional language model like GPT, it can only generate answers based on its internal knowledge, which was gathered during its training phase. While this can work for general-purpose questions, it can fall short when you need specialized or up-to-date information. For example, if you ask a standard model about the latest medical research on a specific disease, it might not have access to the most recent studies, as it was trained on data that may be outdated. This is where RAG comes in. By combining retrieval from external knowledge sources with the text generation capability of language models, RAG retrieves the most relevant documents, incorporates them into the generation process, and produces a response that is both accurate and contextual. Let's break down how RAG works. In essence, RAG operates through two key components: the retriever and the generator. The retriever is responsible for finding relevant documents, text snippets, or structured data from external sources, such as a database or a knowledge repository. These sources could be anything from a company's internal document base to a scientific research database, or even the vast information available on the web. After retrieving relevant information, the generator takes over. The retrieved text is then used to inform and guide the AI's response, ensuring that the output is contextually relevant and accurate. This augmentation of retrieval and generation is what makes RAG so powerful. It ensures that the responses generated aren't just based on the AI's internal knowledge, but are enhanced by up-to-date and domain-specific information from external sources. Let's consider an example in the medical field. Imagine a healthcare professional asking, "What are the latest treatments for diabetes?" A typical language model might provide a general response based on outdated information. But with RAG, the model retrieves the latest studies or medical guidelines from a medical research database, combines that with its own generative capabilities, and produces an informed, accurate, and comprehensive response. This capability makes RAG ideal for industries where the accuracy of information is critical. Now that we understand how RAG works, let's explore the different types of RAG models. While the core concept remains the same, retrieving information and generating responses, there are multiple variations of RAG models, each designed for different use cases. Let's take a closer look at each one. First up, we have the standard RAG. This is the simplest version of the RAG model. In standard RAG, the retriever searches through a set of documents or knowledge bases to find the most relevant information. The generator then uses this information to produce a response. The retriever and generator work independently, but in sequence. This standard model is highly effective for basic question-answering tasks and can be trained on both general and domain-specific data. For instance, in customer support applications, the standard RAG model could retrieve relevant answers from an internal knowledge base to provide customers with accurate and quick responses. Next, we have the agentic RAG. The agentic RAG model is a step up from the standard model in terms of adaptability. It doesn't just follow a fixed procedure for retrieval and generation. Instead, it can adapt its behavior dynamically based on the context of the query. For example, if a query is complex and requires more context, the agentic RAG model might choose a more detailed retrieval strategy, selecting a broader range of documents to pull from. This model is particularly useful for systems like AI-powered personal assistants, which need to adjust their retrieval and generation strategies depending on the type of query and user intent. Self-corrective RAG takes things a step further by adding an iterative refinement process. Once the model generates an initial response, it evaluates its own output and determines if additional retrieval is needed to improve the accuracy of the response. For instance, if the first pass doesn't include enough detailed or relevant information, the model can fetch more documents and fine-tune the generated response accordingly. This self-corrective mechanism is particularly useful in high-stakes fields like law or academic research, where precision is paramount. Knowledge graph-based RAG is where things get even more interesting. Instead of relying solely on unstructured documents, the knowledge graph-based RAG model retrieves structured data from knowledge graphs. Knowledge graphs are rich, interconnected datasets that provide context and relationships between entities. By tapping into these graphs, RAG can generate more structured and contextually rich answers. For example, in a financial application, this type of RAG could retrieve specific financial data points like market trends or stock performance from a structured knowledge graph, providing a more robust and detailed response. Hybrid RAG combines multiple retrieval strategies to enhance the overall response. It can retrieve both structured data, like from knowledge graphs, and unstructured data, like documents or articles, and merge the two sources to generate a more comprehensive answer. For example, in a technical support scenario, the model might retrieve structured troubleshooting guides and unstructured user feedback, combining both to give the most accurate and user-friendly response. Finally, we have the dense and sparse retrieval RAG model. In this version, the system uses both dense retrieval, which relies on semantic embeddings to find similar documents, and sparse retrieval, which uses traditional keyword matching. This hybrid approach ensures that the model captures all relevant information, even if the query is phrased differently from the information stored in the documents. For example, in a legal case search, dense retrieval might find semantically related cases, while sparse retrieval ensures that the precise legal terminology is matched. Now that we've covered the different types of RAG models, let's talk about the benefits of using RAG. First, improved accuracy. RAG's ability to retrieve domain-specific information means that it can generate responses that are far more accurate than those produced by standard language models. Whether you're asking for the latest medical treatments, legal precedents, or product details, RAG ensures that the most relevant and up-to-date information is included in the response. Second, scalability. RAG is designed to handle massive datasets and can scale effectively to meet the needs of industries with large data repositories. Whether it's millions of research papers or thousands of internal documents, RAG can retrieve and process information at scale. Third, domain-specific knowledge. One of the key benefits of RAG is its ability to provide answers from specialized fields. While general-purpose models are useful for broad queries, RAG excels in delivering precise, specialized responses. For example, in healthcare, RAG can retrieve the latest research on a specific condition, while in finance, it can provide the most recent market analysis. Fourth, creativity and flexibility. By combining retrieval with generation, RAG enables creative solutions to complex queries. This isn't just about producing accurate answers, it's about generating responses that are contextually aware and unique. In industries like content creation, RAG can retrieve existing documents and then generate new ideas based on that content, helping writers or marketers come up with fresh, innovative material. And finally, enhanced interpretability. Another benefit of RAG is its ability to explain where the information came from. Because RAG relies on external retrieval, you can often trace back the source of the information, which is crucial in fields like legal research, academic publishing, or financial forecasting. In conclusion, RAG is more than just another AI model. It's a powerful hybrid technology that bridges the gap between traditional retrieval systems and cutting-edge language models. By combining retrieval and generation, RAG offers the best of both worlds: precision and creativity, domain expertise and flexibility, up-to-date information and accurate generation. Whether you're in healthcare, law, customer service, or content creation, RAG is transforming the way we access and use information. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more insights into the world of AI and machine learning. If you have any questions about RAG or how it could be applied to your field, drop them in the comments below and I'll be happy to answer. Stay tuned for more deep dives into the fascinating world of AI technology.